Say, find the coordinates of A and B. The first thing you need to notice is that A and B are actually the points of intersection of the curve and the line. So we have the equation of the line and we have the equation of the curve. Because we're looking at points of intersection, what we know then is that the values of the y's must be the same and the values of the x's must also be the same at the 2 points of intersection. Now, if these two values are the same, it means that the right-hand side must also be equal. If y is equal to y and y is equal to x plus 2, as well as 14 plus 5x minus x squared, then x plus 2 must also be equal to 14 plus 5x minus x squared. And what we've done here is formed an equation where we can now solve to work out the values of x. If we first of all rearrange the equation to get it to be equal to 0, so what I'm now going to do is add x squared minus 5x and minus 14 from both sides, then we would get this equation. Now if we look at what we've got on the left hand side, we've only got one term with x squared. We do have two terms with x, so we can simplify that. 1x minus 5x would leave us with minus 4x. We've got two constants, we've got a plus 2 and a minus 14. 2 minus 14 is minus 12, and it's equal to 0. At this point, you can recognise that we do have a quadratic equation, so I'm going to try and factorise. So I need to find two numbers that multiply to make minus 12, but add up to make minus 4. If we think of the factors of 12 in pairs, first of all, so we have 1 and 12, 2 and 6, 3 and 4. Out of those pairs, 6 and 2 would multiply to make 12. One of them would have to be negative to make it minus 12, and if we think of the 6 as negative, so minus 6 times 2, that does work, it's minus 12, and minus 6 add 2 is equal to minus 4. So I have my pair. The factorising therefore would be x minus 6 in one bracket and x plus 2 in the other bracket. So that means that x minus 6 multiplied by x plus 2 is equal to 0. This means that either x minus 6 is equal to 0 or x plus 2 is equal to 0, which would follow that x is equal to 6 or x is equal to minus 2. If x is equal to 6, I can now work out the y ordinate. I could either substitute 6 into y equals x plus 2, or into y equals 14 plus 5x minus x2, or into both if you want to double check. I'm going to go for the simplest one, I think, which is y equals x plus 2. So if I substitute 6 into this, I get 6 plus 2 instead of x plus 2, which gives me 8. If I do the same thing with x equals minus 2, I would get minus 2 add 2, which is equal to 0. Therefore, one point must have the coordinates 6, 8, and the second point must have the coordinates minus 2, 0. We now just need to determine which one's which one is A and which one is B. If we first of all have a look at where A is, we can see it is actually on the x-axis. Now, any point on the x-axis, the y value would be equal to 0. So it makes sense then that A is minus 2, 0. If we just consider if this makes sense for B, if we have a look at B, we can see it's in the first quadrant, which means that the x and y ordinates must be positive. So it does actually make sense that B is 6, 8. So we have the coordinates of A and B. Now, before we answer question B, we're going to first of all look at some examples. When we've integrated before in question 4b of this exam paper, we had to include a constant term. We used plus c for this. For this reason, such integrals are known as indefinite integrals. With definite integrals, we integrate a function between 2 points so we can find the precise value of the integral. There is no need for any unknown constant terms as the constants cancelled out. Let me demonstrate this with an example. So if we're looking at this first example, we have the integration of x squared and the limits are 2 and 4. This means we need to integrate x squared between the values of x equals 2 and x equals 4. The integration of x squared, so we increase the power by 1 and we then divide by that power, so x cubed over 3. And I've included the plus c, limits between 2 and 4. What this means is we substitute 4 into the integration. So for every x I see, I need to change it to be a 4. So instead of x cubed over 3, I've now got 4 cubed over 3 plus c. I then substitute 2 in, so that leaves me with 2 cubed minus 3, and then I subtract the value I get when I substitute 2 in away from the value I get when I substitute 4 in. If we simplify it, first of all, 4 cubed is 64, so that leaves me with 64 over 3 plus c. 2 cubed is 8, so that leaves me with 8 over 3 plus c. And if I write this out without the brackets, it would leave me with 64 over 3 plus c. And if I'm subtracting everything in the second brackets, it would leave me with minus 8 over 3 and minus c. And as you can see, what happens, the plus c minus c cancels out. And that would always happen. So with a definite integral, you don't need to actually put the plus c in because it would cancel out anyway. My final answer is 56 over 3. Now, how does this link with area under a curve? If I look at this general example, if I have a curve, so I've got an equation here for the curve in a general form, so I've written y equals f of x. So that represents y equals any function of x. And if I want to work out the area under the curve, bounded by the x-axis and the two vertical lines, x equals a and x equals b, then what I need to do is integrate y equals f of x between the limits of a and b, and this will give us the area bounded by that curve, the x-axis, vertical lines, x equals a and x equals b. So that's the general formula for area under a curve. So let's link this back to the exam question and have a look at part B. Remember in part A, we've worked out the coordinates of A and B. So if we just add that information onto the diagram, then we would be left with this. So if I integrate the curve between minus 2 and 6, it would give me this area. It would give me the area under the curve, bounded by the lines x equals minus 2, x equals 6, and the x-axis. So let's do that to start with. We need to integrate 14 plus 5x minus x squared between 6 and minus 2. So integration of 14 would be 14x. Integration of 5x, we increase the power by 1, so it becomes 5x power of 2, and we divide by that power, so we divide by 2. Integration of minus x squared is minus x cubed over 3, and the limits are 6 and minus 2. So we substitute 6 in, and we substitute minus 2 in. Even though you can type this in on your calculator in one go, it's very sensible to work them both out separately, as a lot of mistakes can happen. So if we substitute the 6 in and type that in on our calculators, you should get 102 as an answer for when we substitute x equals 6 in. And if we work out the answer when we substitute x equals minus 2 in, we get minus 46 over 3 as an answer. So we've left with 102 minus 46 over 3, which leaves us with 352 over 3, or you can write that as 117 and a third. So that's the area underneath the curve. If we could work out the area of this triangle and subtract that away from the curve, we would be left with the area that was asked in the question. So I need to work out the area of the triangle. Now remember the formula for area of a triangle. Area of a triangle is half base times height. The question is, what is the base and what is the height of the triangle? If we have a look at the base is going from minus 2 to 6. That would be 8 units. And if we have a look at the height is going from 0 to 8. So that would also be 8 units. So the area of the triangle would be 8 times 8 divided by 2. 8 times 8 is 64, and 64 divided by 2 is 32. The area enclosed by L and C would therefore be the area under the curve minus the area of the triangle. So 352 over 3 minus 32 is equal to 256 over 3, or 85 and a third, and the units, it would just be units squared. Most exam questions that you will have come across with area under a curve, the area in fact has been above the x-axis. You will, however, need to make sure that you understand what to do when you've got an area below the x-axis. So we're going to look at a simple example. Let's have a look at this one, y equals x cubed. To find the area between the curve y equals x cubed, the x-axis, and the lines x equals minus 2 and x equals 2, if we integrate x cubed between minus 2 and 2, we would get x to the power of 4 over 4, with the limits 2 and minus 2. If we substitute the 2 in and substitute the minus 2 in, we would get 0 as an answer. This doesn't make sense and is in fact incorrect. Instead, we have to split the graph up and do two separate integrals. The area above the x-axis is between x equals 0 and x equals 2, therefore the limit is 0 and 2. This gives us 4 as an answer. The area below the x-axis is between x equals 0 and x equals minus 2, therefore these are the limits for a second integral. This gives us minus 4 as an answer. For an area, we must take the absolute value, which basically means ignoring the minus sign. The area for this part is in fact 4. The minus just indicates that the area is below the x-axis. The total area is therefore 4 add 4, which is 8, which makes more sense. So anytime you're working out an area below the x-axis, when you get the negative answer, ignore the minus. The absolute value represents the area.